2016 ADMA Paper 1, question 11, GCE. This was the first paper after we had some changes in the syllabus. This was GCE, and then after this we had another exam in November. So as you can see, this question is a bit unique in that instead of being given the function, we've been given the dy dx. So let's just start with this one and quickly look at the equation we have to solve there. So find p if the integral this is a simple equation provided you know how to integrate. So when you integrate this, you have 8x. Remember, for a constant you just introduce an x, and then when you integrate this you get x squared, and then when you divide the 2 by this, 2 into 4 will give us that. And then we are integrating from p to 2. In fact, we have integrated from p to 2. Then this is equal to 18. So now we can find f of 2, that is capital letter F of 2. So this will be 8 times 2 minus 2 squared. And then we can subtract f of p. So we have 8p minus 2p squared, which is equal to 18. So now we can evaluate this. This is 16. This one is an 8. And then minus, this will be 8p plus 2p squared, which is equal to 18. So this looks like a quadratic equation. So we can start with 2p here, 2p squared. This minus this will simply be an 8. So we can put our 8 here, bring the 18 this side, we have negative 18. Then you have 2p squared minus 8p. This will simply be negative 10, which is equal to 0. And then you can reduce your equation, or you can work it out as it is. I believe reducing the numbers makes your work much easier. So this one will be p squared, that will be 4p, and then that will be negative 5, 0. So as long as you can find the common factor of each of these numbers, then reducing is always the best option. So the product here is negative 5, and then the sum is negative 14. So in additional mathematics, in most cases, not in other cases, in most cases factorization will work. So always start with that. It's actually the easiest. So the product here is 5. So the possible factors can only be these. And then since you want this one to be negative and this one to be negative, we can just negate this. This times this is this plus that is that. So p squared minus, I'll start with p, 1 there, and then minus 5p minus 5 is equal to 0. So p will be, this will be p plus 1, then minus 5p plus 1 all the way to 0. And then we can factor the p plus 1 out, so that we remain with p there and a 5 there. So that means p is either equal to negative 1 or p is equal to 5. So B, we have the diagram below shows a straight line AB and a curve with a gradient function dy dx is equal to 3 minus 4x. The curve intersects the axes at A, B, and C. So A, B, and C. Find the coordinates of A and C. So to find the coordinates of A and C, we need to find the equation of this line and take advantage of the fact that along the x-axis, y is always equal to 0. So we can do that. We have the gradient function here. So from this, we can get our y function. So we can say, I'll just cross multiply there. dy will be equal to, this times this is dy, and then this times this will be 3 minus 4x dx. This may not be necessary to do. You can just straight away integrate this. But once you do this, it shows that you know what you are doing. So I can integrate both sides. Once I integrate y, 1 with respect to y, I'll have y. And then when I integrate the 3, I have 3x. You integrate negative 4, you have, this will be 2x squared, since the power will be a 2, and then you are dividing by 2. You are dividing 4 by 2, which explains this. Don't forget the constant of integration. And then looking at the function here, since we have a point which is 0, 2, we can straight away conclude that c is equal to 2, because the y-intercept is 2. If you want to work it out, you can just say this is your y, you substitute it there, and then your x is 0. So you can put zeros where you have x's, then plus c, and then you realize that your c will equally be 0. So our y is equal to 3x minus 2x squared plus c. So now to find the coordinates of a and b, we already know that y is equal to 0 along this line. So we can just substitute the y in there and solve for x. So this is actually this is 2. So we can put a 0 there, and then 3x minus 2x squared plus 2. So writing this in standard quadratic form, you can start with negative 2x squared plus 3x, then plus 4. So our product will be this times this, which is negative 4. Our sum will be 3. So now for the factors, we can only have 1 and 4, where this must be negated, since the sum must be this times, so this one will be negative 2x squared. Let's start with this one here, or maybe 4x. Let's just start with negative x, and then plus 4x, and then plus 2. It doesn't matter what you start with, by the way. Just use whichever makes your work easier. So I'll factor out negative x here. Then negative x in there is 2x. And then negative x there is positive 1. Then I can factor out a 2 there from here. So I'll have 2x plus 1. And then when you factorize this completely, you have 2x plus 1. And then let me start with negative x plus 2. So this tells you that either x is equal to positive 2 or x is equal to, from here when you make x the subject of the formula after equating this to 0, your x will be negative half. So now let's decide which point should be A and which one should be B. C. So since this is positive, you expect the positive number to be this side. So the x coordinates here will be 0, 2. Then this side, the x value is negative. So obviously this one can be this side. So this one will be negative half, 0. And then finally, find the area of the shaded region. So to find the area of the shaded region, you can find the area below this curve from negative half to 0. Remember, you are not taking this function all the way because we have another function here which is a straight line. So you can find the equation of the straight line first and then find the area below this curve and below the straight line. So this one will be from 0 to that. In this case, you can even say area is equal to half. In fact, we can even do that. So this is 2. So this is 2 and then this one is also 2. So you can find the area of this by saying half BH since this is a straight line. But we shall use calculus anyway. So let's just keep this somewhere. So this one will be like 2 times 2. So we expect the area of this to be 2, even after using calculus. So now, you know how to find the equation of this. Just looking at the line, I can tell that we have something like x plus y is equal to 2. Since it is crossing the x-axis at 2 and the y-axis at 2. So this is the equation. You can use any of the known methods to find the equation. I don't want to make this video too long. So this is the equation. So we can say area will be the integral from negative half to this point here to 0 of the curve. The curve here for the straight line, this is the equation. This is something I expect everyone to know. So from 0 to 2, the equation here is this. So we expect this one to be a 2. So when you integrate this, you have negative 2x to the power 3 and then over 3 plus this will be 3 over 2x squared. Then this one will be 2x from negative half to 0 and then plus when you integrate this you simply get 2x minus x squared over 2. So you're integrating from 0 to 2. So now when you put your zeros there, everything will be 0 minus you put your negative half there. So 2 multiplied by 2 over 3 multiplied by negative half cubed, and then plus 3 over 2 multiplied by negative half squared plus 2 multiplied by negative half and then plus. So we are adding because we have this side and this side. You don't have to subtract here since they are all part of what you want to find. So when you put your 2 there, you have 2 times 2 minus you put your 2 there, you have 2 squared over 2, and then when you put your zeros, everything will be 0. So this times this is 4, and then this is also a 4 divided by 2, so 4 minus 2, it's giving us this, which makes it correct. So you can simplify this. This one will be negative 1 over 8. Or maybe let's just do this. We can reduce the power there, but I don't want to mess up with the negative sign. Anyway, just work it out and then you realize that this will give you negative 1 over 8. Negative and negative will be positive. And then 2 into 8, you have a 4. So this one will give us 1 over 12. And then plus, this is 1 over 4. Multiplied by this, we have 1 over 8. And then this one will be a negative 1, since these two will go. Then plus, we say this is 4, then this is 4 over 2. So that's like 4 minus 2, so that's just a 2. And then simplifying this, we have, let me just punch this on my calculator, and 13. So since this is a negative and we have a negative sign there, this will be positive. 13 over 24 plus 2. So this will simply be 24 times this, which is 48, plus 13. This will be 1, carry 1. So we have 61 over 24 as our area. And of course, for area, you always have square units, and they're done.